Hello, I am Ranjit Kumar. I am applied for the full stack developer position. I have hand-on experience in build end-to-end application from designing database and development set API to creative clean response front. I work with technology like HTML, CSS, Java, React, Node.js, with AI, cloud and cloud tool. I have developed several real-world projects that include web app, data.
Predicting credit risk, it's this massive billion-dollar guess, right? And it literally shapes our entire economy. So today, we're going to look at a really cool project that uses machine learning to take that guess and turn it into a science. Let's get right into it.
So how do banks decide who gets a loan? I mean, it's a question that affects pretty much all of us at some point, right? Whether you're trying to buy a car, get a mortgage for a house, or even start a business, someone, somewhere has to make a call on whether you're a good bet. But how do they actually do that? And more importantly, can we make that whole process a lot smarter?
And believe me, this isn't just some simple decision. We're talking about a super high-stakes game with billions of dollars on the line every single day.
Think about it. Every loan is basically a calculated risk, a bet on the future. And when lenders get that bet wrong, oh boy, the consequences are huge. We're talking about massive financial instability, losses that can just ripple through the whole economy. For decades, this has kind of been a mix of some statistical models and a lot of human gut feeling. But what if we could make it way more of a science?
Well, that's exactly where this project comes in. It's a system designed to do one thing: replace all that guesswork with some serious, data-driven intelligence.
So what is it, really? At its core, the system just takes in tons of financial data and feeds it to these machine learning algorithms. Its one and only job is to figure out the probability that a loan will be paid back, or not. And that is a huge leap from the old ways of doing things. And the real strength of this system is how it goes about it. It doesn't just rely on one single opinion. Nope. Instead, it uses a whole bunch of algorithms all working together. You can kind of think of it like having a panel of expert advisors, Each one has a different specialty, but they're all looking at the exact same application to come up with the best possible answer.
And here's a look at that expert panel. The system uses a mix of different models. You've got things like Logistic Regression, which is great at finding simple, straightforward patterns, but then you also have others like decision trees and random forest, which are amazing at navigating those more complex what-if kinds of situations. When you combine all their strengths, the final prediction becomes way, way more reliable.
Okay, so that's the high-level view. But how does it actually turn a boring spreadsheet full of raw numbers into a clear, actionable prediction? All right, let's pop the hood and take a look.
The whole process breaks down into 4 pretty clear steps. First, it just sucks in all the raw data. Next, and this is a key step, it does something called feature engineering to create smarter data points. We'll get to that in a sec. After that, it trains its team of models, and then finally it puts them through their paces and really evaluates how well they did. It's this logical, repeatable pipeline that takes you straight from data to a decision.
So, to make a smart decision, you obviously need smart data. The system looks at all the key things you'd expect, right? Stuff like your annual income, how much debt you have, how long you've had credit. But it also digs a little deeper. It looks at things like how many late payments you've had and your credit utilization ratio, which is just a fancy way of saying how much of your available credit you're actually using. But here's where it gets really interesting. This is the secret sauce. The most powerful insights don't come from looking at these numbers by themselves. The real magic happens when you start combining them to create totally new, much more powerful metrics.
And that process, it's called feature engineering. So for example, instead of just looking at debt and income as 2 separate numbers, the system calculates a debt-to-income ratio. And that single number is a much better predictor of risk. It's all about creating these new, intelligent data points that give the models a much richer, more complete picture of what's going on.
Okay, so building a model is one thing. That's cool. But proving that it actually works, that's a whole different ballgame. So how do we know this system is any good? How do we know it's accurate?
Well, the system doesn't just spit out a yes or a no. It actually generates a full-on report card on its own performance. It uses all these standard metrics like precision, which tells you how many of its high-risk flags were actually correct, and recall, which tells you if it managed to catch all the people who are truly high risk. This kind of transparency is absolutely crucial if you're going to trust the results. And honestly, for me, this is the most important part of the whole thing. Getting an answer is useful, sure, but getting an explanation, that's powerful. The best machine learning systems don't just give you a prediction and say, trust me. They actually help you understand the why behind it.
And check this out. This chart shows us exactly what the model is thinking. We can see, super clearly, which factors have the biggest impact on its decisions. And look at that. The length of someone's credit history is right at the top, the most important predictor. And right behind it is that debt-to-income ratio we were just talking about. I mean, this kind of insight is absolutely invaluable if you want to build better, smarter lending strategies.
Okay, so we've got this really powerful tool. Now the last piece of the puzzle is, how do you actually use it? We need to make it accessible and easy to work with. And the great thing is, this system gives you two really solid options. On one hand, you have a simple web interface. This is perfect for, say, a business user or an analyst who just needs to check a single application really quick. On the other hand, for the developers out there who want to plug this logic into a bigger automated pipeline, you can run it straight from the command line. That kind of flexibility makes it a super practical tool for pretty much any situation. You know, when you step back, this project is just a fantastic example of using machine learning to bring real clarity and accuracy to a super complex, high-stakes problem. It's all about moving from guesswork to actual data-driven decisions. And it kind of leaves you with this really fascinating question, doesn't it? If we can do this for credit risk, what other huge billion-dollar guesses are out there just waiting for the right data and the right algorithm to come along and solve them?